this website I pulled up, whatever you call it, a web article, whatever it is. It's called Iron and Turfgrass. It was put online, it says here, on May 5th, 2021. And it was put on to the Lebanon Turf website. And there's no author. I've looked and looked. I would give credit to the author, although he or she may not want it after I go through it. But I wanted to go through this because this Lebanon Turf web, there's several articles in here that are just wonderful examples of propaganda and true information blended with misinformation. And the question I always ask myself, a lot of it's particularly on iron. I'm fairly knowledgeable on iron. I kind of have a general understanding of the system. I'm not convinced that anybody really understands the system with iron, whether in the soil or in the plant. Even in the literature, there's only one or two authors who may not even be alive anymore, who I really think understood it. And that's not me. So it is a very complicated issue. There's the redox potential and the changes and the electron donations and acceptance. It's insane, the complexity of iron in the soil. So I'll give them that. I don't know if anybody really understands it. But this article is not that... the content in it is not particularly difficult to actually go measure. And clearly whoever wrote this hasn't actually measured it. So let's get through this. It's called Iron and Turfgrass. And we're going to have a scientific article at the end. But Iron and Turfgrass on Lebanon website right now. And this is a very short one. By the way, I have a much better article on this website if they don't take it down. I won't even mention the title because I don't want them to take it down. That I'm going to go over whenever I get to fertilizer blending, because it's propaganda to an extreme I've rarely witnessed. So I'm going to go over a better one, but this one we're going over is because we're going over iron. So this is why I went to this one today. It starts off and says, iron is considered a micronutrient for turfgrass. Iron is a key component of proteins and plant enzymes involved in nitrogen metabolism, plant respiration, and chlorophyll synthesis. Due to its role in chlorophyll synthesis process, iron level can impact turf color in many situations. That's true. Iron in the plant, as we saw, what was it, yesterday, or the last was it on Friday or Thursday or Wednesday? The relationship between color and iron that's in the plant is very strong. And I think we even show that today in this article as well. Turfgrass will absorb iron via the roots. The iron will be in a stable reacted form. Examples are shown below. Each source has a different iron content and a different availability to the turf via water solubility. So the reason I said that earlier about I kind of have a general grasp of the system earlier, I said that I often wonder how other people are able to decipher what's true out of this stuff. Because I don't think really anybody understands iron in the soil very well. I kind of have a basic idea, sort of. But I imagine, perhaps incorrectly, that the majority of people don't really have much of a clue at all. And it's those people that are out buying the fertilizer a lot of times and spreading the fertilizer. And I often wonder, well, how would they find out? How this is epistemology, right? So how do we know what we know about iron in the soil? How would just an average Joe, read this? Would they read it as this is true? Or would they read it more critically or skeptically? I don't know. For me, I can read these things and for the most part pick out all the flaws and inaccuracies and so forth. But it often concerns me that stuff like this, propaganda like this is written, and I think the majority of the people probably don't care, but probably also don't possess, the people who do care might not possess the necessary knowledge to make informed decisions. And we hear this stuff over and over and over again, and it eventually becomes or we eventually become convinced that it's true, when in fact it may not be true. So that, I don't know, that concerns me. I don't know what I'm going to do with it, but anyway, I guess that's why this channel exists. Anyway, he shows ferric sulfate, ferrous sulfate, iron sucrate, ferric oxide, ferrous oxide, chelated iron, and organically derived iron. He shows a list of these products. There's a whole bunch of other iron sources as well, but for the granular sources, those are most of them. The words ferrous and ferric designate the oxidation state of the iron atom, ferrous referring to Fe2, which is relatively soluble in water, and ferric referring to Fe3, which is only somewhat water soluble and only in acidic soil and acidic environments, pH of 6 or less. We're going to get into pH and iron. Iron oxide typically contains both ferric oxide and ferrous oxide. Iron sucrate is iron oxide combined with sugars to reduce staining risk. Discussed later. Now, we've discussed that before. That is true. Iron oxide is just iron sucrate is iron oxide that's just been crushed, or it's the leftover, remnants of iron oxide that they reaggregate with sugars. Chelated iron features iron paired with a chelated agent that can be spray applied. It is easily absorbed by the turf. I don't know what his definition of easily is, but we're gonna discuss this. Organically derived iron refers to the iron present in sources such as biosolids and compost, normally at a very low percentage. Now, that's the one source of iron I was never able to actually test because I didn't want to bother trying to balance out everything. When you're dealing with iron, particularly in turf grasses, when you just when there's a tremendous amount of organic material and lignins and all sorts of stuff, the solubility is I can't express it enough. It is immensely complicated. And when you're dealing with an organically derived iron and you're trying to determine whether or not there's going to be a response to that specific form of iron, it's not easy to remove all the other factors and only look at that. It's very difficult. And I just didn't want to mess with it because it became very, very challenging to figure out. I wanted to know, could you actually get a response only from the iron from, say, milorganite or something? And I never bothered doing that because it was just too difficult. For turfgrass, the generally accepted target range for iron level in soils is 30 to 100 parts per million. That's definitely not true. I'm not convinced at all that that's true. I should say I'm not convinced that that's true. There is no consensus accepted range for iron on soil tests. So to say this 30 to 100 parts per million is just being naive or ignorant, or I don't know what it is, but that's not accepted by soil scientists, at least not this soil scientist. Turf deficient in iron suffers from chlorosis identified by a pale green overall color. Usually the reason for chlorosis is that the iron in the soil is not available to the plant, especially in alkaline soil conditions. If the soil pH can be adjusted down to 6 or so, the iron in the soil will become available and the turf color should gradually improve. Now, if there is one soil scientist that I would say understood iron at least better than anyone I have been ever aware of, it was Dr. Lindsay, who published all these iron papers in the 80s and 90s. And I don't think he would agree with that statement. I can't read his mind. But when this particular person is saying adjusting the pH down to 6, the iron in the soil will become available. I will show you my own research where we applied iron sulfate to many soils. One of them as low as 5.1. I think another one was 5.3, which obviously is below 6. And that iron became unavailable within 24 hours. So when you hear things like this, it can kind of sound convincing because you might be indoctrinated into believing that lowering soil pH will somehow result in an increased greening from soluble iron. You may have heard it so many times that now you believe it. When in reality, there's very little evidence to support that. Clearly, there's evidence to support the solubility of iron changing as pH goes up or down. I'm not here to debate that. What I'm talking about is in a reality, in an applied practical setting in the field. If you're going to reduce the pH from 7 or 8 down to 6 or 5.5, you're going to take the time and money to do that because you think it's going to increase the soluble iron in the soil to a point where you'd see a turf response to that. That's not supported by most of the evidence that I'm aware of. And this particular person says, reduce it down to 6.0 and it'll be soluble. And I'm just not convinced that that's true. And I'll show you why I'm not convinced that's true in the coming weeks. Some turf fertilizers have an iron content of 1 to 3 from iron oxide. The intention of this fertilizer formula feature is to supplement the iron level resident in the soil. I would say that that's probably untrue. I mean, iron oxide isn't going to... The solubility of iron is dominated by the insoluble form of iron in the soil, by the solid form, I should say. It could be not just insoluble, it could be like a amorphous sort of iron. That is the driving sink of iron, is pulling all that iron out of solution. That's the driving factor, is the solid phase of iron in the soil. That is true. But the intention of the fertilizer formulation containing iron oxide is not that. Coming from someone who's blended thousands of tons of fertilizers, I can tell you with a great deal of confidence that the intention of including iron oxide in fertilizer formulation is because iron oxide has the highest percentage of raw material of iron in a raw material, 50 or 55%, depending on where you get it from. And you only have to add a little bit in there to get the iron on the fertilizer tag to go from 0 to 3. So when you're dealing with a fairly full ton of fertilizer, you may only have 50 pounds or 100 pounds left that you can add something into it. Well, you're not going to increase the percent iron in the fertilizer from, say, an EDTA or an EDDHA that much. Very little. And you're talking on the decimals of percentages when you're going to add it into a ton, because the raw material is so low. But the raw material of iron oxide is 55% or 58%. It's very, very high. And so you only have to add a little bit to get that percentage to go up in the ton, and that can convince people to buy it. That's, in my opinion, why iron oxide is used in granular fertilizers. It's a game of deception. Whether or not the iron actually results in a turf response is not the responsibility or the interest of the blender. They're simply adding that because they believe that the end user has asked, get my iron up to 3% or 5% or whatever. I want iron in there. Well, they can't do it oftentimes with low analysis raw materials. They have to use high analysis raw materials. And the highest is iron oxide. This is an economic benefit, but the iron content is derived primarily from ferrous oxide. So the soil pH needs to be 6.0 or below to see any effect. So he's stating as a matter of fact that the iron oxide in this is not going to be soluble until it gets below the soil pH gets below 6.0. It says any visual effect such as a deeper green color will also be minor and slow, perhaps several weeks. It'll be several weeks. It will definitely be several weeks before you ever see a turf response to iron oxide. That iron oxide is so strongly formed, I guess that's the practical way of saying it, for any practical reason, practical purpose, any practical definition, it's never going to be soluble again for any, in any meaningful sense to us. Geologically, it will become soluble at some point in the future. Okay. But for us, I'm talking about any time between the next 6 months to the next, say, 10 years, you're not going to see any visual benefit, any response to applying iron oxide, even if the pH is below 6.0. As long as the soil pH remains in the range for adequate plant growth, optimal plant growth. I mean, if you go down to 1 or very, very low, ridiculous pH, I imagine there'll be some iron become soluble from iron oxide that low, but that your turf would be dead by that point anyway. So as long as it's, in the 4s or 5s, where your plant can probably survive still, you're not going to see any appreciable amount of soluble iron from iron oxide. So this is again, I'll say I'm not convinced that that's true. And I'm becoming more and more convinced that it is not true. So there's a difference between saying I'm not convinced it's true versus saying I'm convinced it's not true. And I'm slowly being convinced that it's not true, which is a much stronger statement than saying I'm not convinced. Anyway, it's not semantics. That's for another conversation in the future, maybe. When applying granular iron compounds to the soil, When applying granular iron compounds to the soil, be aware of the risk of staining on flat surfaces, particularly light colored concrete. If the iron particles are crushed on the concrete by tires, human shoes, or even heavy sweeping, rust-colored stains will appear that can be found objectionable and difficult to remove. Now, this is, I don't know how to explain this, but I mean, technically it is true, but it's not true. I mean, it doesn't have to be crushed. Whoever wrote this has never actually gone out and measured and taken the time to determine iron staining from these iron sources, because you don't need to crush these particles. All it has to do is remain on the surface if it's soluble in water to come in contact with it, and it'll dissolve and stain within, it depends, but within 5 to 20 minutes, you're going to see a red or brown stain on the concrete from something like iron sulfate. You don't need to crush it. Iron products based on oxide or sulfate are known for this undesired property. Now, I've done a lot of staining work with iron products, which I'm about to show you on the very next slide, where I've never seen a staining from iron oxide ever. And I don't think it can really occur, because the staining itself is a chemical stain that is the result of the oxidation of the iron on the surface of the concrete or paver or whatever. And in the case of iron oxide, the iron's already been oxidized. There is no more iron to oxidize. So from iron sulfate, it's soluble. And so when the iron comes in contact with the dissolved oxygen in the water, it'll oxidize out. And when that happens on the concrete surface, it'll form that red or brown stain. But iron oxide will not stain, as far as I'm aware. I've never seen it stain. I'll show you a slide in a second that showed it didn't stain. So again, I just don't think the person who wrote this knows what they're talking about. Particles landing on susceptible surfaces should be lightly swept or blown into the turf. Iron sucrate can be used as an alternative to reduce the risk, but particles should still be removed. Iron sucrate does reduce the risk of staining, but there's no known response to turfgrass from that product, so it's kind of useless. So, I don't really fault the person who wrote this for not understanding iron. I don't understand iron, to be frank. I mean, I don't know if anybody does. But when you're talking about staining and stuff, that stuff's easy to measure. All you got to do is go out and put out some iron sulfate particles on your curb and sprinkle a little water. Don't use bottled water. You got to use water that has some dissolved oxygen in it. But when you put a little water on there, it'll stain in about 5 or 10 minutes. It's not complicated. Do it next to oxide, and you'll see nothing happen. And here's what I mean by that. This is a project that I did years and years ago. In fact, let's see when it was. 9 years ago. So 9 years ago, I was working for a fertilizer company, and I did this little project at my house in Gainesville. And I took all the iron granular products that we had available through the blending plant, as well as manganese and magnesium products. And I put them all on one paver to get one shot of them all at the same time. So let me explain. I'm not going to play this video because I don't like listening to myself on this video. This video has me in it, and I don't want to listen to it. So anyway, I used all the iron, really all the iron, manganese, magnesium options that we had available in the blending facility. And I want to walk through that with you here, so we're all on the same page of knowing what's going to happen or what can happen from the application of iron products on concrete. Because the idea of oxides can stain is out there. The idea that chelates won't stain is out there. Okay, so let's look and see what happened. Just so I set the stage here, what I did was I took a few granules of each of these products, each of these raw materials. So just straight iron sulfate, just straight iron EDTA. And I put 2 or 3 granules in this little squares. You'll see the numbers on the screen here. For those listening, I have a paver in front of me, and there's little numbers from 1 to 20. And it's a square paver. And in the top left-hand corner, I placed some granules, and then I moved to the right of the paver. And then I moved down, and I put another row of granules. And there's 4 rows. There's 4 rows and 5 columns. And there's just a few granules that I put in each of the little spots designated by the number. And the first number over here in the top left-hand corner is a dark red-brown stain, and that came from iron sulfate. The next one over came from polymer-coated iron sulfate, and you can only see a few little dots where the iron dissolved through there, okay? So the idea that you can slow release, so what this means is for the difference between these two is that you're not going to see a stain from polymer-coated iron sulfate, but the oxidation of iron will occur. You can see two little dots from the polymer-coated iron sulfate. The oxidation of iron will still occur once it dissolves through the polymer membrane. So it can still happen. In other words, the iron that's going to be released from that is still going to oxidize. It's still going to have very little benefit to the turf. Not just because you're slow releasing, it doesn't negate the oxidation process. Number 3 is VIG iron. VIG iron is a water treatment residual that they treat not wastewater. Actually, it's not a water treatment residual. It is a water treatment residual, but not from wastewater. It's from like river water, if I remember correctly. Could be wrong on that. Someone can correct me and put it in the notes. But you see very little staining from that. But the staining's still there. Now let's look at iron chelate, polymer-coated iron chelate. The polymer did not do much at all to this particular chelate. This was EDTA. And you see a very dark brown red stain from the iron chelate polymer coat. And right next to it is the same chelate that's not polymer coated, and you see a red stain. Dark red brown stain. So this concept or this idea that floats around in the turfgrass sphere, oh, use iron chelates, it won't stain. Well, this would indicate that they do stain. Okay. Iron sucrate is over here. This number 6 is iron sucrate, and you see a grayish sort of haze of a stain over here. Iron sucrate is iron oxide. It's just been crushed. So this little gray stain, I didn't get a macro or a close-up photo of this, but this grayish stain is not a stain. It's just the particles have been dispersed. It's actually those gray, that gray color is actually the particles of the material itself that didn't dissolve it. It dispersed into the actual concrete, porous concrete itself. So it's not staining the concrete, but it does give it an appearance of grayness. And then 7 right next to it is iron oxide. Right here is iron oxide. So on that article, it's saying iron oxide is notorious or well-known or whatever for staining. Well, no, it's not. Iron oxide's already been oxidized. Okay. It's not going to stain. It's also not going to provide, and that's the reason it's not going to provide any value to your turf. There's no solubility of the iron in the iron oxide granule to start reacting. There's nothing there. 8 is activated sludge. So here is this was not Milorganite. This was either Huactinite or the Jacksonville biosalt. I can't remember. But there was no staining from this. It doesn't mean there wasn't any iron being released. Maybe it was being released and it was preventing it from staining, or maybe none of it was being released. I don't know. But there was no staining from activated sludge or biosolids. The 9 is a frit. Which, if you don't know what frits are just like a grouping of oxide mineral or oxide micronutrients, and we didn't see any staining from that. And then 10 is a 5-in-1 product that's used in nursery that has all 5 forms of iron: oxide, sulfate, chelates, all these things in it, and you do see some staining from that. So the article we just mentioned about oxide and sulfate staining, sulfates will stain as much as anything. They will stain some concrete. They'll stain wood. They'll stain whatever, light poles, and they'll stain metal, whatever. It will stain, but oxides will not stain. Oxides are useless in turfgrass management. Agronomically, they're of no value. So don't think, oh, well, I'll use oxide because it won't stain. It won't stain. It also won't provide you any benefit at all. Okay? It's already been oxidized. We need to use that iron before it's been oxidized. Just because we're here, and I'm probably not going to go back to this anytime soon, the manganese and magnesium are on the next 2 rows. Manganese oxysulfate is the first number here, and we see a light yellow, orangish haze of color that's been stained. So that's oxysulfate, a blend of oxide and sulfates, and you see a staining there. And then right next to it is manganese sulfate. So we have manganese sulfate number 12, which is a dark red, brown, severe stain, compared to iron sulfate, which is also a dark red, brown, severe stain. I could not tell the difference between these two. If you gave them to me and you showed me 2 stains, I wouldn't be able to tell the difference between the 2. One's manganese and one's iron. So if you have manganese sulfate in your fertilizer, it is soluble. and it actually will remain soluble a little longer in the soil than iron, depending on the pH, but it will stain. It will stain just as much as iron sulfate. Manganese sucrate, so it's the same thing as iron sucrate. Nothing there. You see a dispersion of the particles and you just see a gray haze. 14 is manganese chelate. So here's chelated manganese, and you see a stain. It's not quite dark brown red, but you do see a stain from manganese chelate. And then NutriPlus was a nursery material. And then the next row down, you see all the magnesium sources: potassium, K-mag, polymer coated K-mag, crop mag, dolomite fairway grade, and dolomite micro grade. And you don't really see much stain. You might see a tiny bit from dolomite fairway grade, maybe, but that's not much there. So the point is, magnesium is not going to oxidize near as readily as the irons or the manganese. And I've mentioned that before in a prior podcast. Magnesium, well, did I say that backwards? Magnesium will not oxidize like iron and manganese. The magnesium remains soluble for prolonged periods of time in the soil. It is less affected by pH, and we have very little likelihood of seeing a response because it remains soluble in the soil. The soil already has soluble magnesium in it in many cases, so adding more isn't going to help. But when you apply it to concrete, you're not going to see much at all in terms of staining from magnesium. Okay. So I just wanted to mention that while we're here. I thought it was a good opportunity because we had the Lebanon propaganda piece saying, whatever they wanted to say about iron. It's their website. They can say whatever they want to say. And I can take their website and explain to you why you shouldn't believe much of it, because lowering the pH to 6.0 is not going to suddenly solubilize iron from iron oxide. I'm going to show, again, I keep saying I'm going to show you. I'm trying to get chronologically through these papers because there's many more important papers than my papers. But my papers are at the very end. I'm going to show you that, where iron oxide and sucrate and all these things aren't going to result in much of anything at all. And certainly the solubility of iron, even from soluble iron sulfate, doesn't stay around for more than about 24 hours, even when the pH is down to 5.0. So iron from iron oxide sure is not going to do that.